turn on your camera so we can see each other face to face without mask, okay? Hi guys. All right, I guess we'll get started. Most of you guys are online already. There might be a couple that's still on the way, but let's get started. And as I said, if you could turn on your camera, we can see each other face to face, okay? So let me share my screen to start with. All right. So today, over here in the presentation mode of here. All right. So starting from today, we'll be talking about kinematics. We'll be in chapter 2 for the next 4 lecture or so, okay? Just one final reminder, homework number 1 is due tomorrow. It's due at midnight tomorrow. I see many of you guys have already finished your homework number 1. That's great, okay? And then number 2, I'll probably post number 2 tomorrow, if not today, okay? So keep an eye on number 2 tomorrow. At some point you'll be able to start working with number 2. Now we'll just have number 2 home will be mainly on chapter 2, so we'll just start today. So maybe just a couple of examples, couple of problems you can start working with, okay? So last time we talked about the dimensions and units. So as you know, for physics problems, a lot of times we are using different quantities, okay? Or some people would prefer to say different dimensions, but most of the time we will talk about quantities, okay? So in this chapter, we will talk about motion in 1 dimension, and then we will talk about some quantities to describe the motions, okay? And then to use those quantities, we'll be able to get some information out of some known quantities, okay? So in this chapter, we'll be talking about the terminology list here in red here, displacement, speed, velocity, and acceleration, okay? So those are the 4 main quantities we'll be talking about. All right. So to describe quantities or to use any quantities, we first have to have a reference point, okay? So you can use different reference point, it's up to you. But the first thing you want to describe a quantity or an object here is by knowing its position, okay? And then the position is basically described by relative to a certain reference point, okay, our reference object. In this case, is relative to the buildings for the picture shown here for people, okay? So, then if you know the position of an object at different times, then you can compare or you can calculate the change in positions, okay? So in this case, we'll introduce now a quantity called displacement here, okay? So displacement is the change in position, all right? So change in position in physics, so this is something you guys want to get familiar with, okay? So in physics, when you are talking about change in some quantity, then what you do is you do the final of that quantity minus the initial of that quantity, okay? So change in position, then you'll be doing final position minus initial position. Okay, so that gives you displacement, all right? And then for the reference, or we call frame of reference, that can be random, okay? You can choose a frame of reference as you like, okay? But once you choose a particular frame of reference, then you want to stick to it, okay? You do not change the frame of reference in the process of working out the problem, okay? For almost most of the cases. Okay, in some particular cases, you might use two different frames of reference, but you want to be very careful about handling those scenarios. Okay, we'll probably talk about that in coming chapters or so. Okay, for that particular case. All right. So, all right. So in this slide, we have two quantities introduced. The first one is position, is where an object is at any particular time, and then that's with respect to a particular frame of reference. Okay, and then displacement is simply the change of the position. Okay. So, and then in physics, you'll see that most of the time we are using symbols to represent a quantity. Okay, so for position, then in this case, if this is one-dimensional problem, then we use x. Okay, we'll pick a reference point as the origin of the coordinates, and then we'll take the x position, okay, or the x axis to represent the position of the object. So for example, a professor lecturing in a class, if she goes back and forth, so it's she's moving in one dimension in one line. So you can take the horizontal line as the x-axis. Okay, so then her initial position, you can use x naught. Okay, so a 0 here pronounced as not, x naught, and then final position is x final. Okay, you can also call xi, which excuse me, I being the initial position. Okay, now to calculate her displacement, and you simply will be doing x final minus x naught, which is the equation, the first equation in the chapter here. So delta x would be the change. So the delta sign here, the triangle, it's pronounced as delta, and that represent the change in position. Okay, so whenever you see a delta sign in this class, that means the change of the quantity. Okay, so delta x means the change of the position. So it's final minus initial. Okay, so change of a quantity is the final of the quantity minus the initial of the quantity. Okay, all right. So in this case, if you take a certain point over here as the origin, okay, we are just focusing on the x direction. Now we can just ignore the y direction over here because she's not moving in the y direction. So if she is initially 1.5 meters away from the origin, and then final position is 3.5, so then the change of her position or displacement will be 3.5 minus 1.5, okay, which is 2.0. Okay, and then in the figure here, it shows positive because actually change of position could be positive or could be negative. For example, if her initial position is at 3.5, final position is at 1.5, then you are doing the other way around. You're doing 1.5 minus 3.5, okay? Then you end up with minus 2.0 meters, okay? So there's a sign here which indicate for being positive, indicates her change in position is in the opposite direction, in the positive direction, okay? And then if it's minus, that means her change in position is in the negative direction of the x-axis, okay? All right. So again, for right now, I'm going to just mute you guys all to reduce any background noise, okay? In case if you want to talk, you can unmute yourself. All right, so if you have questions, you can unmute yourself and just speak out, okay? All right. Okay, so as I said, because displacement is change in position, so if this is one dimension, this dimensional motion, you can have change in position either in the positive x direction or negative direction. So that means displacement actually has a direction, okay? So for example, if I go from my home to workplace, then I'll be traveling, say, like 25 miles, more or less, and then in the direction of northeast, I'll be going northeast in that direction to workplace. Okay, so you can say 25 miles in the northeast direction. Okay, then that means that's my displacement. Okay, so displacement has a direction as well as a magnitude. Okay, so for some quantities you can just use magnitude. Okay, say certain meters or certain kilograms. Okay, and then for some quantities you need magnitude as well as the direction. Just in this case, like displacement. Okay, it needs direction as well as a magnitude. Okay, and then if a quantity needs both direction and magnitude to describe it completely, then it's a vector quantity. Okay, we'll talk about that in a little bit later. Okay, otherwise, if you can describe a quantity just by magnitude, then it's a scalar quantity. Okay, so for example, distance. Okay, so the distance, for example, the distance between my home and workplace is about 25 miles. So then you can just say 25 miles. Okay, you don't need a direction for that. So then distance is a scalar quantity. Okay, so in this case, we want to distinguish between vector quantity or a scalar quantity. Okay. All right. Now, distance is being defined. I didn't mention it, but in the last slide or in this one, it's defined as the magnitude or the size of displacement. Okay, between two positions. All right. So if you have two positions, if you have initial position, if you have final position. Okay, so then distance is between those two positions. Now, distance traveled, on the other hand, okay, it's the total length of the path traveled between two positions. Okay, so to give you an example of what's the difference between distance between 2 points and then distance travel between 2 points or two positions. Okay, so look at the left figure here. So if you are starting with the initial position over here, x naught, the right point on this figure here. Now you are going leftward. Okay, 3 kilometers. All right. Now this data x1, that means your displacement. Okay, in your first part of travel, you go leftward. That means you are going in the negative x direction. Okay, so minus. So that indicated negative 3 kilometers. All right. Now you decide you want to go back. Okay, so after your first part of travel, you come back. All right, for 2 kilometers. Okay, so data x2 is your displacement for this particular part of your travel. Okay, now in this case, for your second part of travel, the final position is over here, but now the starting position for the second part is here on the left end of this travel over here. Okay, so you can see you go from initial position to the final position now in the direction, positive direction. So your displacement is 2 kilometers in that case. Okay, so then in this case, if you wanted to, now in this case, for the total of your journey, for the entire journey over here, you are starting from this x naught, you are ending at this x final, right? So your final position and initial position, they are just 1 kilometers apart, right? You go 3 kilometers to the left and you go back 2 kilometers. Now your final and the initial position is just 1 kilometers apart, right? So the position or the distance between these two positions is just 1 kilometers, right? But the distance traveled for your total journey, it should be the addition of the total path length. Okay, so that means the total length of the first travel, which is 3 kilometers, all right, plus the 2 kilometers. So the total distance travel here is 5 kilometers, all right, where the distance between the two points positions is just 1 kilometers, right? Okay. I would like to pause for a second here for any questions you guys might have, because these two terminology may be a little bit confusing. Okay, so let me know if you have any questions. Okay, so distance is just the um, distance between two positions. Okay, and then distance travel between two positions might be different from the distance between two positions, because you might be taking multiple trips, all right, for the journey. Okay.
I have a quick question.
Yes, go ahead.
So for distance for this one, would we write it as 1 kilometer or would we write it as like -1 since they're
Um,
traveling backwards?
yes. So for distance and the distance travels, they are always positive because you are taking magnitude of the displacement. Okay, so that means you are taking the absolute value of it. Okay, so be always positive when we are talking about distance. All right, when we are talking about displacement, it could be positive, it could be negative depending on direction. Yeah, thank you. That's a very good question. All right. So let's move on if you guys have no more questions on this too. All right. Let's take a look and quick example here. All right. So in this case, again, you are looking for distance travel, all right, of the ball, which should be the total length of the passes. Okay, so it takes two passes to get to the final hole here for the golf ball. So you would be you probably will figure out that you'll be adding the two up. Okay, and then for the displacement, okay, it's just the final position minus initial position. Okay, so go ahead and then do this. If you have your answers, you can click on the link here, then you'll be able to submit your answers there. Okay, so I'll give you guys a couple minutes on this. All right. So let's take a look here. So let me just stop sharing this right now so my camera view will be zoomed in for you guys to better see this. All right. So since you put the golfs into the hole in 2 trips, okay, so then there's first part of it, all right, starting from here, this is the final, okay, and then this is, so the first one here goes from here to there, that would be your x1, okay, so the first trip, then the ball goes back at the x2, the second trip, okay, so you can see for the distance traveled, it's always going to be the distance of the passes that is for the travel that takes place, okay, so will be this one, x1, and then for distance, you always take the absolute value of it. So you'll be saying, okay, the absolute value of delta x1 plus absolute value of delta x2. Okay, so let's say this is delta x1, this is delta x2. Okay, so then in this case, this is 10 meters for the first part and then 2.5 meters here. So for delta x1, then it will be 10 plus 2.5, right, meters. For delta x2 will be 2.5 meters. So then the total will be 50 meters, okay? And then many of you guys, most of you guys got this one right, okay? So 50 meters, okay? Should be 50 meters because it's 10 plus 2.5 plus 2.5, okay? But for the total displacement of delta x, then you'll be doing just x final minus x zero, okay? Which is difference from these two positions, which is 10 meters, okay? And then if you call the to the right to be positive, then it will be positive, okay? So for the first one, it's going to be 15 meters. For the second one, it's going to be positive 15 meters, okay? Now, any questions you guys might have on this one? Okay. Let me see, let's chat message here. Okay. So if you want to submit the Google Doc, you want to pull the PowerPoint slides on your end, okay? So, and then on that particular page, we have the problem. You click on the problem. It's URL embedded. You should be able to click on that, okay? If you click on that, it will be directly to the page to submit the answer. Or if you click on it, it will pop up a link, and then you click on the link. Okay, will bring you to where you can submit your answer. Okay, so let me know if you still have problem with that one. Okay, all right. Now let's get back to the lecture slides here. Okay. All right. Now, let's officially introduce the concept of vectors and scalar, okay? We have already looked at actually the real example of it, okay? So for displacement, it's a vector quantity. For distance or distant travel, it's a scalar quantity, okay? So any quantity that has both magnitude and direction, that is a vector quantity, okay? And for example, velocity, when we talk about velocity, then we talk about how fast the object is moving at, and then in what direction. Okay, that's a velocity. So that's the difference between velocity and speed. Okay, speed is just how fast the object is traveling. It doesn't specify in which direction. Okay, and then force. So force will have a direction. If you are exerting a force on an object, then you are giving a certain amount of force, say 10 newtons or 20 newtons, okay? And then you also give it a direction. You'll be either pushing it in one direction or pulling it in another direction, okay? So there's a direction and also a magnitude of force. So those quantities are vector quantities, okay? Scalar quantities just have magnitude. For example, temperature, okay? It's just say 80 degrees, okay? Or for energy, it's just certain joules, okay? Or certain calories. Or maybe like mass. Mass is just say an object is 2 kilograms, okay? It doesn't specify any direction. You don't need it, okay? So those are scalar quantities, okay? Now, coordinate system, as I said, you always want to have a frame of reference. Okay, so particularly when you are dealing with quantities that has magnitude, then you want a coordinate system. Okay, so the most common one we are using is an XY coordinate system. Okay, so this is referring to a two-dimensional problem. If you have just one-dimensional problem, then you can just use X axis. Okay, for the frame of reference where the it's referred to the origin. Okay, and then if you have two dimensions, you can use y. Okay, sometimes you can use y axis only if it's just a one-dimensional motion. Okay, for example, if the object is just moving in the y direction, then you can do it that way. Okay, so and we'll see several examples later on in this chapter and the next chapter. Okay, so if the object is just moving in the vertical direction, you can just say you want to pick vertical direction to be a y direction. Okay, and then but you can also specify that as x direction. Okay, so on the coordinate system, okay, for which way is x-axis, which way is y-axis, it could be arbitrary. Okay, so but by convention we take horizontal to be x, vertical to be y. Okay, so that's the convention we take here. But anyway, it's arbitrary. You can say you like to say vertical is x, okay, and then horizontal is y. That's fine. Okay, it's up to you. But once you have a particular coordinate system set up, then you will stick to it. Okay, you do not change it during the way of working out your problem. Okay, so once it's chosen, you fix it. All right, but it could be arbitrary at the initial place. All right, so that's vectors and then coordinates. Okay, now let's look keep moving in this chapter. So the next section here talks about time, velocity, and speed. Okay, so a lot of times when we are describing motion of an object, okay, we are referring to multiple time instants. Okay, so then in that case, time plays a role here. Right, so time is the change or interval over which change occurs. Okay, so for example, if you're starting from one point, ending at a final point, so then there's certain time involved. Okay, could be like 5 seconds, could be 5 minutes, could be 5 hours. Okay, so that's the change between those two instances where they occur. Now the SI unit for time is second. Okay, so we'll be talking about a lot of quantities, and then we'll pretty much stick with SI units here in this class. Okay, which is the international standard units. All right, we will not use the English units system so much in this class. So when a particular quantity is introduced in the first place, we'll talk about its SI unit. Okay, so for time, it's second. Okay, we use S, lowercase s as its symbol. All right, so time elapsed, which means the change of time, delta t, and we use small t for time. Okay, now you probably remember in last chapter when we say dimension of time, it's capital T. So for dimensions, we always use symbol of capital letters. Okay, but for quantities, we can use either lowercase letters or we can use uppercase letters. Okay, so in this case, we'll use lowercase t. Delta t means change in time, so tf minus t0 or t naught. Okay, so final time minus initial time. And then for simplicity's sake, okay, we always take the starting of the motion to be time equal to 0. Okay, so time can start from any point you choose to be 0, but if we take that, then it will simplify our calculation because t0 then is 0. Okay, so we usually take length convention. But again, you can say, okay, I want to be the starting motion of the time instant and the starting motion the object to be t equal to t0 equal to 2 seconds. Okay, it's up to you. All right, but usually when it's given in the problem, it's assumed that when the object starts the motion, it's equal to 0. Okay. All right. So then, if we take t0 equal to 0, then delta t is equal to t final, right? Because delta t is equal to t final minus t0. All right. Now, this symbol with 3 lines, okay, also means it just means equals to. It means always equal to. Okay. So then in that case, t final is always equal to t. Okay. It's just another notation says equals. That means it always equals to. Okay. All right. Now, the next quantity in this section we would like to talk about is average speed. Okay, so speed is simply how fast is the object moving at. Okay, so for the average speed, okay, so between 2 instants or 2 positions, if say an object moving from position A to position B, so in this case the snail moves from one position to another position. Okay, so then we can calculate its average speed. We will be doing distance divided by elapsed time. Okay, so d divided by t, the distance between its final position and initial position divided by the time it takes. Okay, so that gives you us the average speed. Okay, we use v as the symbol for speed. Okay, so v is equal to d divided by t. The SI unit for speed is meters per second. Okay, t will has SI unit of second, and then d, the distance, will have SI unit of meters. Okay, I think I forgot to mention that when we talk about distance. So distance has the SI unit of meters. Okay, so then our speed equals to meters over second. Okay. And then we are talking about average speed because the speed can vary. If it travels from point 1 to B, it might go faster at the initial, say initial 5 meters, and then later on slows down. Okay, but that's fine. We are talking about the average speed between these 2 points. Then we will be just doing the total distance divided by the total time it takes. Okay, that gives you average speed. Okay, and then for instantaneous speed, it's defined as the speed the object is moving at a given instant. Okay, so as I said, the snail, when it goes from initial position to final position, its speed may be changing. Okay, or for just the same case that if I'm traveling from home to school today, then I don't probably always move at 60 miles per hour, right? Sometimes I'm at 40 miles per hour, sometimes I'm at 60, and then sometimes I may be at 50, okay? But if you're asking me my average speed, then we'll be just doing the total distance divided by the total time it takes, right? But if you are asking me what's the instantaneous speed at a given moment, say at 8:30, then I probably will be looking at my speedometer and then say, oh, okay, it's 50 miles per hour at that instance, okay? So my average speed might be 45, but my instant speed will be changing all the time, okay? All right. Now let's take a look on this example here, all right? So this one says kangaroos have been clocked at speeds of 65 kilometers per hour. How far can a kangaroo hop in 3.2 minutes at this speed? And B, how much time will it take a kangaroo to hop 2.25 kilometers at this speed, okay? So pay attention to the units here, all right? So you probably want to do unit conversion at the first place, okay? For A here, it's asking you how far in meters can a kangaroo hop in 3.2 minutes, okay? So you probably want to convert the speed into meters per minute first, okay? Or you can do kilometers per minute first, and then at the end, your answers then will be in kilometers, and then at the end you can convert kilometers to meters. Okay, so again, I will give you guys a few minutes on this one to try it out, and then we can look at the solution together. Now, so we'll be playing with equation here that we just learned. Okay, so in this case, you'll be using the velocity equals to distance divided by t, or the speed equals to that. Okay, so v is the speed here, and then we are looking for distance in part A here, and then in part B here, we'll be looking for time t. Okay, so in this case, v is given as 65 kilometers per hour, and then t is given as 3.2 minutes. Okay, in the second scenario here, you'll be using the same v equals to 65 kilometers per hour, but you are given distance as 0.25 kilometers, and then you are looking for t in the second case. In the first case, you are looking for d. Okay.
I have a question.
Yes.
Would you like the answers to be with like sig figs and that?
Right. So in this problem, it's given the quantities, known quantities to be two sig figs. So you want to keep your final answers in two sig figs as well. Yeah. Thank you.
Thank you.
Mhm. All right, let me wait for another 30 seconds or so before we look at the solution together. Okay, so for the first one, I see most of you guys got that one right. It's 3,500 meters, or 3.5 times 10 to the third. Okay, and then the second one, it's about 14 seconds. Okay, so many of you guys have that one right as well. So let's take a look here. All right, so on the first one, A here, you're looking for D, so then you'll be starting with this equation. Now to look for D, you multiply both sides by T, okay? So multiply by T, so then you get T times V equals to D, or D equals to V times T then, okay? So V is 65 kilometers per hour, and multiply by 3.2 seconds. Okay, so I want first to convert my unit from hour to second. Okay, so hour is down here. I put hour up there, minute down here. In 1 hour, there's 60 seconds or 60 minutes. Okay, so that will take care of the hour. Now I can multiply this by 3.2 minute. Okay, so that minute will be taken care of as well. So then 65 multiplies 3.2 divided by 60, which will give me 3.466, okay, in kilometers. So this is in kilometers, then you do the conversion at the end here from kilometer to meters. That will get rid of the kilometer. So 1 kilometer, that's 1,000 meters there. All right, so that this gives you 3,466 in meters. And then as Jaden pointed out, we need to pay attention to the sig figure here. So keep 2 sig figures. We want to use scientific notation here. So 3.5, okay, you round it up, 3.5 times 10 to the third, okay, meters. Okay, and then some of you guys say 3,500. That should be okay as well, okay? Now, one thing I would like to point out is for expert TA, you guys don't have to worry about sig figure so much because it does it's not very particular about sig figures on expert TA on the homework assignments. Okay, so sometimes it may be better off you keep more digits than required. Okay, in that scenario when you are doing homework. Okay, but just keep in mind that we need to if somebody is asking about what's the correct SI, the sig figures here, then you should be able to answer that, okay? So this is A here. Any questions anyone might have on A? Okay, so if not, then for the second part here, again, V equals to D divided by T. That's the only equation we learned so far. So you're looking for T this time, okay? So for some of you guys are so familiar with algebra, you can quickly figure out, okay, then T is equal to D divided by V. Okay, if not, then you can do this slowly. You can multiply both sides by T, okay? Then you get T times V equals to D, all right? Then you divide both sides by V, then you arrive at this, right? T equals to D divided by V. All right, now in this case, they can do, because D is given 0.25 kilometers, V is the 65 kilometers per hour, all right? Then this will give you the time in hours because kilometers will be canceled out. Now the denominator in the denominator will become numerator, so BH, okay, here, up here. And then you typing in the numbers in your calculator, it will tell you this is 0.003846 in hours. Okay, I see somebody. Let me double check. I think I got something like. No, I didn't see that in your responses, but okay, so this is in hours. All right, now it's asking you the time in seconds, so then you want to convert hour to seconds. So put hour down here because that's numerator there, and then they will cancel out. So 1 hour here is 3600 seconds. Okay, that will give you 13.846 in seconds. Okay, and then keep the appropriate significant figures. It will be 14 because you just need 2 sig figs here. All right. Questions you guys have? Okay, if not, then let's move on here. All right, so the speed is only described by magnitude, okay, say 65 miles per hour, okay? Now, as I mentioned, velocity is a vector quantity, which is the vector quantity of speed, okay? So it's actually defined as displacement divided by the elapsed time, okay? So it's delta x divided by t, not distance divided by t. So you can see delta x, displacement, it's a vector, okay? So then the velocity should be also a vector because there's direction involved here, okay? Now, if you notice that I put an arrow on top of v to indicate this is a velocity quantity, okay? So if you see an arrow on top of quantity, that means it's a vector quantity, okay? So you want to describe it with magnitude as well as direction, okay? And then also for delta x, which is change in position, that's a displacement, okay? So you can see in this time, I also put a arrow on top of it, so that indicates it's a vector quantity. For time t, it's not, it's just a scalar, so just t, okay? And if you are doing a vector quantity divided by a scalar quantity, it still give you a vector quantity, okay? Or a vector multiplied by a scalar, then it also gives you a vector quantity, okay? All right. So in this case, let's say if you take a trip to a grocery store or any kind of store here from your home, you start from your home to the store and come back. So your total displacement here, it could be 0, right? Because you are ending up at home again. So your change in position is 0. So that means your average velocity will be 0. Okay, that's right. Because velocity, it's a vector quantity. Okay, but if you are talking about the average speed, which is scalar, then which is the distance traveled divided by time t. So distance traveled in this case will be 3 plus 3, the onward and then backward, okay? So 6 kilometers. And divided by the time it takes. If you take, if it takes 30 minutes for the round trip, then it's half hour, okay? So then it's 12 kilometers per hour. That's your average speed, okay? But your average velocity will be 0, okay? So take a note here because velocity is a vector quantity, okay? It's equals to displacement divided by time takes. So displacement in this case is 0, all right? But distance travel is not, okay? Any questions you guys might have? All right, if not, then we'll move on to the next topic here. So a lot of times it's easier to visualize the movement of an object by looking at the graph or graphical representation of it. Okay, so in this case here, starting from your home to a store, so then your position change is like this, okay, as time elapses. Okay, so you have the position as the vertical axis, the time as the horizontal axis. So then a quarter hour, 15 minutes, you reach to the store, okay? And then you're coming back. So a position coming back to 0 here, starting from 0 to 6, and then go back to 0 here. All right, so in this case, you can see your velocity versus time. So for the overall velocity is 0, but for velocity for a particular part of it, so for the ongoing part of it, then it's this displacement divided by time, right? So 6 divided by 0.25, which is 12, okay? And you are coming backwards, you are reversing your direction, so then the velocity becomes negative because velocity is a vector quantity. So it has a positive direction on the onward part, and then the coming back part is negative direction, so it becomes negative here, 12, okay? So 12 here, negative 12 here, okay? So then overall average velocity is 0. But for the speed, it's just the magnitude of the velocity, okay? So it's 12 here and then 12 here. You are taking absolute value of the velocity, okay? So again, keep in mind, this is similar to distance and displacement, okay? So distance is the absolute value of displacement. Now, speed is the absolute value of velocity, okay? So if you take absolute value of it, then it's going to be just always positive, okay? In this case, because you are moving in just one direction, so then you can say positive, or you are just moving in one line, one dimension, so then you can say positive to be, or onward to be positive and then backwards to be negative, okay? So in that case, you can simply, if this is a one-dimensional motion, you can simply use positive or negative as to indicate the direction of the quantity, okay? So for example, for velocity, you can say minus to be the going towards the positive direction at certain speed, and then negative of something to be going in the negative direction of it, okay? So this is on the graphical presentation of this. All right, now let's look at we have a few minutes remaining. Let's take a look on the next 2 slides here, maybe quickly. On the instantaneous velocity, okay, so instantaneous velocity, as I said, as I drive, so for example, if this is something like for a trip, if you are going from one location to a second location, so your velocity probably varies, okay? Now, when we are doing velocity, we say we are doing delta x divided by delta t, right? We are doing change in position over change in t, right? So then in graphical representation, this is the velocity is pretty much nothing but the slope of the curve, right? So if you are going from point A to point B, all right, in the green curve over here, just ignore this blue here. Or let me go back here. So if you are doing this one here, the previous slides here, if you are doing from your home to store over here, all right, then you are doing delta x over delta t. Okay, so from this point to this point, delta x, this will be the position x. This is not the vertical axis, as you can see. Okay, so delta x over delta t. So this is rise over run. Okay, so which gives you the slope of it. Okay, so if you have a position versus time plot or graph, then you can take the slope of particular part of that to give you the velocity of it, because velocity is defined as delta x over delta t, okay? So rise over run gives you the slope of that line. And then on the backward, from start to home, you'll take delta x over delta t. That gives you, again, the slope of this guy, which is minus of that, okay? All right. Now, this is the average velocity, okay? So instantaneous velocity, now if you look at curve like this, in the blue here, blue curve here, at a certain point, so then if you are looking for the instantaneous velocity, you'll be looking at any point, a point over there where you have the tangent line of that point, okay? Then the slope of that tangent line will give you the instantaneous velocity of that particular point, okay? Now, other than that, if you are going from, say, point A to point B, you are doing delta x over delta t, then it's this slope of this line will give you average velocity from this point to that point particularly, okay? And then say from point C to point D here, if you are doing delta x of those 2 points divided by delta t, will give you average velocity of that, okay? If you are looking at the slope of any 2 points from the curve, okay, connected with a line, then the slope of that line will be giving you average velocity of those 2 points, between those 2 points, okay? Now only at the tangential position, you'll have the instantaneous velocity of that particular moment, okay? And so another example over here, okay? So if you are looking for between position 1 and 2, okay, then this 2 point will give you, this slope of this green line will give you average velocity, okay? And then between 2 and 3, slope of this green line will give you average velocity of between 2 and 3. Now, if you take a tangential line of this curve at this point 3 here, then the slope of the tangential will give you instantaneous velocity at that particular time instant, okay? All right, any questions you guys might have on this one? Okay, if not, then we'll coming back on Wednesday for the lecture. Again, if you are signing up for Wednesday's lab section, then we'll see you in class on Wednesday, okay? And except you are requesting for lecture online only, okay? So I see you guys online, some of you guys online on Wednesday, and then some of you guys in class, okay? And then remember this, starting from this week, we'll have lab 1, okay? We'll have lab this week, okay? So we'll see you guys also in lab, okay? So that will be it for today, okay? See you guys and have a good day. Bye.